Evet, herkese merhaba. Ben Atatürk Üniversitesi Tıp Fakültesi Patoloji'den doçent doktor Sevile Özmen. Bir sürekli tıp eğitimi toplantısıyla ile birlikteyiz ve bugünkü konuğumuz Almanya Augsburg Üniversitesi Tıp Fakültesi Hastanesi'nden Profesör Doktor Yakup Zinsels. Doktor Linsens özellikle beslenme alışkanlıklarında önemli olan yaşam tarzı faktörleri, metabolizma ve kronik hastalıkların önlenmesi arasındaki etkileşime uzun süredir ilgi duymakta. Bu alanda çokça araştırma projeleri ve kohort çalışmaları mevcut. Güncel araştırma konuları kronik hastalıkların ve komplikasyonlarının önlenmesi, hedeflenen müdahale için yüksek risk gruplarının belirlenmesi, nüfusa dayalı kesitsel ve kohort çalışmalarına, hasta gruplarına ve epidemiolojik kayıtlara dayanan araştırmalardan oluşmakta. Evet, Augsburg Üniversitesi Hastanesi Epidemioloji Başkanlığı'nı yürütüyor 2021 yılından beri. H faktörü 104. 2019-2022 yılları arasında Alman Beslenme Derneği Başkanlığı, 2019-2023 yılı arasında Avrupa Beslenme Dernekleri Federasyonu Yönetim Kurulu üyesi olan Profesör Linsens, 2020'den beri de Almanya Gıda ve Tarım Bakanlığı Bilimsel Danışma Kurulu üyesi. Aynı zamanda NACO Sağlık Araştırması, Diyet ve Yaşam Tarzı Faktörleri uzman grubunun başkanı. Evet, hello Professor Linsens. I'm happy about your participation in your program. Yes, Abdul, you have to say?
Okay. Hi, and we are pleased to have my colleague Professor Yakup. He's a high caliber scientist, as civilized in Turkish. Just very simply, like Yakup, like he has like more than like 480 like document scopus. Is outstanding, like H index like more than 100. So we are happy to have you with us, and we are pleased that you can share your experience as a specialist in epidemiology to our audience. Please, Yakup.
So thank you very much for this nice introduction. I'm sorry I cannot speak in Turkish. I have to talk in English. And
Yes.
I try to share my screen now. Can you see it?
Yes, Yakup.
Yes. Okay, then I can start?
Yes.
Yeah. Yeah. So it's my pleasure to talk a bit about epidemiological studies. So the title is Establishing and Analyzing Epidemiological Studies. And as you can see from the first slide, we have a lot of different types of epidemiological studies. We roughly separate it in observational studies. So this is the left-hand side of this slide, and experimental studies. So I will focus here on observational studies, which means not doing any intervention, just observing the study participants. And I will also stick to especially cross-sectional studies and cohort studies. And you will hear later why I'm doing that. So let me begin a bit with a definition of epidemiology, because people are always a little bit afraid about what is that. So it's very easy. It's really easy. As you can read here, it deals with the spread or the burden of diseases. And it's not only the diagnosed diseases, it's also disease-related changes or functional changes, or if you want to talk more general, it's health-related conditions. So we are talking about diseases, their causes, and their consequences. And we're doing that with our view on the population. And this is what makes epidemiology different from a kind of clinical sciences or clinical medicine, because we always have it focused on the populations or population subgroups, and not as compared to physicians treating individuals with a certain disease, right? So that's why I start with this kind of very rough slides here. The question of what is it when I'm saying I'm looking at the population level? So what is the definition of a population? It's not an easy question, and I'll give you here some examples of what it could be. Maybe you say you want to look at all adults in Germany. There is no definition of an age range. There is no definition of other subgroups. So all adults in Germany, is that really feasible? So it's 80 million, more than 80 million people. I would say it's hardly feasible, except for some examples like a mortality register, right? We could also use a group, so make some further examples. We can also say, I want to identify high risk groups, for example, for colorectal cancer screening in Bavaria. So then I have the population in Bavaria, maybe adults at a certain age, yeah, or we want to talk about a population which we define as all cases of myocardial infarction in a certain city, especially here, the city of Augsburg and adjacent counties. So this is our study region, actually, and we have here a complete myocardial registration, infarction registry. Yeah. Or another study, another example from us, we wanted to study outpatients with a diagnosis of COVID-19. And then we thought, how can we do that? And our population-based approach led us to the decision to invite all of these subjects, these patients from the county of Augsburg in a certain time range. So it's not any kind of specific convenient sampling. It's a definition of an underlying population so that we know what we are talking about, right? Then, of course, the questions come up how to approach them. It's often not very easy. It becomes more and more difficult to do so. And also the question of the time range that you have to face with. And at the very beginning of each study is the question, what is the aim of the study? So what do I want to do with that populations? What do I want to learn from them? So it could be a simple description of occurrence of diseases, let's say the prevalence of diseases. It could be that you want to follow the time changes of the number of diseases over time. So then you have to have different assessment periods with the same instruments. Or you want to identify risk factors for different disease, for a specific disease. Then in that example, we would like to stick to cohort studies. The first two examples would apply to cross-sectional studies. Okay. So we have then, yeah, as I said, as I showed you at the first slide, different possibilities. And as I said, we always again and again have to use cross-sectional studies and surveys and registers. So this is or the headline here is descriptive epidemiology. It is not limited to description. You can also do some analytic studies in there, but it's um, it's more meant to be descriptive. You can generate some hypotheses about exposure disease associations, but you cannot go very close to kind of causal associations. That's why we, in the second part, stick to the example of cohort studies, which is the best, the high quality type of study before you can start an experimental study. Yeah. Okay. Then, when you have your question, when you have decided on your population, um, then often the population is far too large to be investigated as a whole. So then you have to have a subsample of this population, and in the ideal cases, it's a random sample. That means that you get close to a representative sample, and the sample has to be as large as necessary. So you can do some statistical calculations. You have to define your type of study, and then from the results of this subsample, of this subpopulation, which is then your study, the results of the study should allow you to draw conclusions on the population. And you can imagine if the participation rate in your study is low, so you will not meet any kind of representative data, then you have a problem for your conclusion on the population level, right? Okay. So as a last slide of some general issues, I'm often talking about exposure and outcome. So exposure is a factor that we are interested in relation to its effect on uh, the development of a disease. could be a risk factor, could be also a protective factor. So this exposure outcome relationship is what we are very often studying in observational epidemiological studies. And I highlighted here the cross-sectional and the cohort studies as well. And you can see here two major issues of these two study types. In cross-sectional studies, you do the assessment of exposure and outcome at the same time. So you see each participant one time, and in that time, you ask them different questions, you make some examinations. So there is one point in time only, which contrasts the cohort studies. So in cohort studies, you start with the recruitment where you can ask a lot of questions, do a lot of examinations, and later on, you follow these people. So you get information on a second time, a third time, a fourth time. So you have here this concept of follow-up. When you do the evaluations, you exclude people who had the disease at the start of the study. So you're following only those at risk of getting a certain disease, right? So that you have here this time frame inside, and that's what makes cohort studies so much better for studying exposure outcome associations. Let me give some examples or some information about the first point, cross-sectional studies. Here we can describe exposures, different types of exposures, as you can think of. We can describe outcomes, assess outcomes and describe it. And you can see here the major types of studies that we're using here. Cross-sectional studies, I will follow here further. But here's also listed population statistics. So for Germany, for example, we have a national mortality statistics. I think it's also true for Turkey, where you can use data, not only total mortality, but also cause-specific mortality, and look at the development of mortality figures over time, right? We also have some disease registers that you can use, but in Germany, we only have very few ones. It's the cancer registration that is working nowadays fine, I would say, but there are not many more. So our myocardial infarction register is one register in a certain area of Germany, in Augsburg, which provides data for the German national health reporting, right? Because we do not have a national myocardial infarction registration. Cross-sectional studies, we are doing that again and again for especially these reasons here. Cross-sectional studies can be done quite quickly, and that's why it's cheap. So it's a limited amount of money and person time that you need to do the study. And if it's the suitable study design for your study question, then we have to, or we can use this type of study design. And if you're doing that again and again, you have these time trends, the secular trends, and you can also do some kind of hypothesis generation if you link exposure factors and outcomes, but here we have to be very careful. We have a lot of disadvantages, and this is related mainly to this concomitant assessment, so the assessment of exposure and outcome at the same time. So we are very far away from our aim to get close to causality. And we are talking about prevalent diseases and exposures at the same time. So the problem that we are more and more facing with these cross-sectional studies is related to this third point, misinterpretation in case of lack of representativity. Yeah. So if we want to make a statement on the population level, then we should have a subsample that is, yeah, kind of reflecting the population. And if participation rates are decreasing and decreasing, and now in our last study, I will show you later on, we have a participation rate of 30%. So it's hard to have a high participation quote, and so we have this problem of misinterpretation very much so. Some examples for Germany. So we have health surveillance in Germany. It has to be done by every country. It's set by WHO, right? So it's done for adults and also for children. And we have separately diet surveillance studies. You can see here the National Food Consumption Survey 1 and 2. 2 is 20 years old. Also, the Bavarian food consumption is 20 years old. And we are just finishing the current Bavarian food consumption study as a cross-sectional study. And here we experience this 30% participation rate. One of the most famous studies is, of course, the ENHANCE study in the US. You may have heard about that. So, National Health and Nutrition Examination Survey. Um, um, and in this survey in the US, which is meanwhile a continuous survey, you have a lot of instruments that are used to cover health situations and health related questions as well as nutrition related questions. So we didn't manage that in Germany to combine that. But the US did that, and they have different focuses at the different rounds of assessment. You can see here some examples: children's growth and development, or infectious disease monitoring, and so on. And you can see here that Heinz started very, very early in 1971 and developed further. And now it's a continuous study, a continuous surveillance in the US on health and nutrition. And if you do that so often, regularly with the same methods, you can nicely show such time trends, right? Here it's diabetes, total diabetes are the filled uh, um, quarters here. So you can see that the prevalence of diabetes increases from 1999, 2000, up to 2007, 2008, and now it's more or less constant. I would expect that, so it ends here in 12, that it's still increasing due to the increasing prevalence of obesity. Okay, so that's only an example. Another example that I would like to show you is what we did currently, the Bavarian Food Consumption Survey 3. So we aimed here to get a random sample of the population aged 18 to 75 years, German-speaking Bavarian population, in a period 2021 and 2023, exactly where the COVID pandemic was running here. So we are describing the dietary habits during COVID, which we didn't expect to do so, but still it's valid information also for coming up with recommendations, especially recommendations for the Ministry of Health, Health and Agriculture. Here it's another ministry who funded this study. It's the Ministry of Agriculture, Nutrition and Forestry. Okay. What did we do there? We had different methods. So we started with a face-to-face interview. Uh, we asked them to fill in a questionnaire. We did some blood collection. You can see here these dried blood spots that we collected and sent to a laboratory, or directly measurement of random glucose. We asked them to measure their waist circumference, and after this personal visit, they got phone interviews on their diet on the day before, so the 24-hour diet records. We did also a sub-study. So this study was across Bavaria, across entire Bavaria. And we did a sub-study in Augsburg where we re-invited, first we oversampled the subjects in the region of Augsburg, and then we invited them into our study center and did a lot of, examinations, additional questioning, and also the collection of biomaterials, um, uh, focusing on the immune system and related diseases, especially metabolic diseases, inflammatory diseases, and also allergies and infections. Some some views here on our equipment in the study center. You can see here what we can measure in our small study center. It's really small. So we have some nice possibilities like indirect calorimetry, or we have also ultrasound device to get an impression of the liver, so size and color of the liver, vessel diagnostics, ergospirometry, cognitive testing, and also biosample collection and storage, and direct analysis of immune cells with a FACS analysis, which is possible because our lab that we can use is very close to our study center. So we can immediately bring the blood samples to the lab and analyze it. I already talked about this problem of representativity in these cross-sectional studies. Um, we can conclude that it's not possible to have a representative samples, but to be as close as to. And usually, if we want to make statements about the population, we have to use correction factors. So weighting factors for the statistical analysis to correct for the deviation of your sample or our sample from the underlying population, right? And what we always can do is to present stratified analyses, stratified results. So if you subdivide the population into sex groups, age groups, and so on, you can give information about the situation in these subgroups without the need for rating in the statistical analysis. Yeah. So maybe that's a bit interesting to you. Here is an example from the BVS2. It's the study 20 years ago, where we still had, or we still could achieve a participation quote of 71%. So it was fine. It's very, very much acceptable in contrast to the current situation with about 30%, right? So what I want to do next in the next few slides is to talk a little bit about practical issues, about practical aspects of how to implement and analyze such a study. And I want to start with a first point, which is your scientific question and your scientific study plan. So the first point headlined here by fundraising phase is because we usually have to go for additional funding from external sites to develop a study plan, a scientific study plan, which you can submit to an agency or whatever. Yeah, here we have to know first what is the aim or the aims, which population, which sampling procedure for the population, which measurements do you want to apply, which questionnaires. Usually we use validated questionnaires, not self-constructed, because only these validated questionnaires can be used properly. And you have to define also time frame or other time aspects. Do you want to collect dietary information from work days or weekend days or alcohol intake? Yeah. So all that should be finalized and included in the science study plan that you can then submit. And hopefully you get funding. And the next point is then to prepare your field work. So to be prepared to start the pilot study, I would say. For that, you have to have a clear view on what you need that has been defined in the study plan. So you know you want to measure body composition with with a bio device. Then you need to have a standard operating procedure. So we are writing standard operating procedures and we are training our personnel with the standard operating procedures so that everybody in that study center, or if you have more study centers across a study, then that everybody is doing it the same way, exactly the same way. 2 points that makes a lot of that are very important in Germany, let's say it this way, is the question of ethical clearance and the data protection issues. So if you have not clarified that for your study, you're not allowed to start a study. So it's very important. And for ethical clearance, you have to prepare the informed consent form, info material for the participants, and also what you report back to the study participants. So we are sending all that material all together to our ethics committee for clearance. IT requirements, databases, ways of how to collect data digitally, also directly in feeding a database. That's what you also have to define and prepare for or decide for. So we have done all that. Then we can start with our study. No, I would say For a large study, there is often the question, there are new instruments that you want to use, so you have to decide which device exactly. For example, in a study, we wanted to measure physical activity with accelerometers. So which device should we use? Then you have to have kind of a feasibility study to help to decide for one specific instrument. And what we always do is to have a pilot study before starting the main recruitment phase. So pilot study means that you have your full program ready, staff trained, database programmed, and so on. And you can start with, I would say, 5 subjects, 10 subjects, to see whether this program works, whether there are uh, new problems that you didn't think of, whether there is a different or wrong order of the different instruments. So make first the cognitive testing and then the blood collection, whatever. So this is really important to do that, and then you can start the the main phase. And in this main recruitment phase, we call it also field phase. We always do the continuous monitoring of the response rate to see whether there is a problem with certain groups. For those who did not participate, we have a so-called non-responder questionnaire with some key features, some key parameters, so age, smoking, BMI, alcohol use, and so on, that we can, in a way, judge on those subjects that didn't want to participate. Okay? And we have the need for continuous quality control. Quality control means that, especially if you have a longer study duration, let's say 1 year, 2 years, you have to look at your personnel. Maybe you have to retrain and recertify your study personnel. You have to look at your data in the database, whether there is some inconsistencies, some uh, ideas of differences between investigators, between study nurses, between study physicians. So this is what you always have to do during the field phase. And if you then completed your study, your study cleaning, your study data cleaning started. Yeah, so of your data, the number of missings, plausibility checks between different questions, and yeah, here a specific point for dietary studies. You can compare your responders versus non-responders for these key questions that you ask the non-responders. And what we usually do, not always, but if we don't do that, we have always the same questions. So we wanted to have transformed variables before we send data sets for scientists to analyze the data sets. So the definition of BMI is very simple in principle, but different researchers may define it a little bit different. So it's best to do it centrally and define these transformed variables, at least these which are usually used in every analysis. And for the specific analysis, then we prepare a scientific analysis plan, including also the statistical procedures that we are foreseeing for this analysis. Yeah, let's talk a bit about the the statistical questions. So for the descriptive statistics, you would say, or you would expect it's easy. Yeah, sometimes it's very easy. So I started here with frequency for categorical variables or distribution measures for continuous variables. But it's often and quickly quite complicated. So I recently looked at our MI register data. So we are reporting that for each year. And then we have here complicated variables that you have to be very precise to understand what exactly meant here. So if you have prevalence data, you may want to present it as prevalence rates. You may age standardize the prevalence rates to make it comparable across countries. So if you do all these countries do the same standardization, and then quickly it turns out to be quite complicated sometimes. What we always can do in descriptive analysis as well is subgroup analysis, and this waiting for the correction to correct for the deviation of the sample from the underlying population, as said before. If you then look at this possibility. I already said it's only for hypothesis generation to link exposures and outcomes in cross-sectional studies where you do this assessment at the same time. So you're talking about prevalences. Then you can do also linear regression modeling and also logistic regression models and other regression models. You can do that, but please be aware and careful with the interpretation of these results. We really do that sometimes, but we have always to state that it's a cross-sectional study and it's not close to some kind of causality proof, right? So let's come to cohort studies and talk a bit about cohort studies. It's the preferred this study designed for analyzing exposure disease associations. As I said, the definition is quite easy, I would say. A group of subjects not suffering from the disease of interest at the start of the study is observed, is followed up over a longer time frame, and then we analyze differences in the probability of newly diagnosed, which means incident diseases, depending on exposed or non-exposed situation. There are also some nice pictures which I brought here with me. So we start here with the study, start of the study, recruitment, and we are question we assess data with questionnaires, with physical examinations, with imaging techniques, whatever you want. And then we follow them up over time. That's why I made this time in red. And you would then collect outcomes by different ways. We come to that. But here we are getting as close as possible to this causality question. The closest, of course, is the experimental study design. Another way how to formalize that or to make a graph about that, we're standing here at the beginning, recruitment. So the physician is here, the study physician, and then we are assessing and following up over time to get information about occurrence of disease, decrease in functions, and so on. So the time is the point, and that's why I have this extra slide here, which shows you 1, 2, 3, 4, 5, 6, 7, 8, 9 subjects, 9 participants in that study. So the blue ones are exposed for a certain condition. Let's say they are smoking. The black ones are non-exposed. And then is the question, who gets an endpoint of interest? Let's say total mortality or lung cancer. Let's say lung cancer. So smoking and lung cancer. It's the example that I show you later on as well. So this person got a diagnosis or died, these 4 persons, right? And then you calculate in your study the person time. The person time is the sum of each individual person time and means from the start of the entry in the study, which could be also here, until the last information or the diagnosis of the disease of interest. Yeah. And you sum all these months or days or years. So we often call that at the end person years up to get a summary estimate of the follow-up time. Yeah. And this is the time under risk. So we need this information about time under risk, and we need the information about the possible endpoints during follow-up. And this is listed here. Possible results are either the event, the end of an event happened before the end of follow-up. What is the end of follow-up? The end of follow-up could be the end of a study, but often we use this term end of follow-up at a certain time point. So after 10 years of this cohort study, we want to do our first evaluation. And then we are saying end of 2023, we want to make a data set. And using this date means that all events happened before this date are included, and the time under risk ends in each subject as the last information of this subject. Yeah. So you really calculate for each person in the study this observational time. So if end of follow-up would be here, you would have the person time from that person from here to here. Yeah. And you add that up. So back again, possible events during follow-up are the disease was defined or diagnosed, no event at all. Subjects could leave the study. So you're using the last information of the subjects in that study. Or there is a concurrent event, for example, death from other causes. If we have the example lung cancer, they could die by other causes, of course. And then you sum up all these individual observation types. Um, Cohort studies, you can also list advantages and disadvantages. And you can see here a list of a lot of advantages. And that's also why we're doing that, because the disadvantages are really also overwhelming. So the point here is really the blind assessment of risk factors at the very beginning, before onset of a disease, before onset of a new disease, I should say, because we are focusing on the incident cases, we are excluding the prevalent case. Yeah. And then you can also study multiple effects of one exposure factor. If you have a nice assessment of physical activity in a cohort study, you can link this physical activity. You can explore the association of physical activity with many different diseases. So with lung cancer, with myocardial infarction, with diabetes, with depression, with again, all what you have in your cohort study. That's why it's really um, giving a lot back if you manage to set up a cohort study and follow the cohort over a longer period of time. Yeah, the clear advantage here is the clear time sequence between assessment and onset of disease, so we are closer to this question of causality. And we can estimate relative and absolute measures of the occurrence of diseases and the risk factors. And this type of study also allows for efficient sampling of rare exposures. The disadvantages are, as I said, I think I used the wording overwhelming. It's long lasting. It's very expensive because it's so long lasting. It's not suitable for rare diseases. So in this case, you have to stick to case control studies, and you have to, yeah, take care of your cohort. What you in any case try to avoid is to have a high loss to follow up. So many people that are saying, "Oh, I want to stop being part of the study, so don't send me a letter again." So you want to have a high follow up over a long period of time. I didn't talk about biases. We epidemiologists always talk about biases in the studies. I didn't talk about biases in cross-sectional studies. Here is a list of biases in cohort studies. I think I don't want to go through that in detail for the sake of time, but there are, of course, a lot of things epidemiologists can talk over hours and hours. I want to, I prefer to show you some examples. There are very famous cohort studies. The most famous one, the first one, is the Framingham study in the US, or the British Doctor study in the UK. You all know about the Boston cohort, so the Nurses' Health Study, for example. I made two studies in Greenwich. The first one is the EPIC study. It's a large European cohort study. The first one with a large biobank. And I had the chance to work in EPIC Heidelberg. It's one of the two German centers in EPIC. And I will show you some results from that study. UK Biobank is a very large, recently or currently running biobank cohort study. And in Germany, we set up kind of in parallel to the UK Biobank study, the narco health study with about 200,000 participants. So let me give you some information about this EPIC study and the narco health study. You can see here the European study from the very south to the very north of Europe, promising that there is a high diversity of exposure, of dietary exposure. Diet is the focus here, diet and cancer risk. Um, And you can see that recruitment period in Heidelberg. So here's the Heidelberg Center, and here's the Potsdam Center, the two German centers, was between 1994 and 1998. And I can show you here nicely the follow-up, what that means in practical terms. So follow-up means that we started a written follow-up. We send it out postal letters to the participants the first time after finalizing recruitment. So immediately after finalizing, we started with sending out the letters, which was a short letter, a lifestyle questionnaire, so asking for changes in lifestyle and asking for new diagnosis or health problems that came up during the time since recruitment. Then the second follow-up, again a written follow-up. We had a food frequency questionnaire in there, and that's why it took so a long time to get that completed. Then the third follow-up was added, and so on. So you continuously are in contact with the subjects, and that's also a chance to give some feedback to the participants, to keep them involved in the study, to keep them informed, and they are really interested in the study. So if they decide to take part in that study, they are interested and they want to know what you're doing and what you're getting out with their personal data. And for this endpoint data collection, we have a mixture, usually a mixture of the different possible methods. Here in Epic Heidelberg, we have this active follow-up. So self-reports on these written letters, on these written questionnaires. We started with linkages with clinical registries. That was not so very successful. Um, Limited to some diseases. So you have to decide, okay, I want to have that now validated information about stroke cases. And then you can try and link with your clinical partners. What we always have to do is to check the vital status. In Germany, it's the municipal registry that we can contact, but they only can tell you dead or alive. And if dead, you have to go back to the local Department of Health in Germany to get the death certificate and some idea about the cause of death, right? Okay. So it's complicated, time consuming, and you can see here on this slide a column where it's headed Epic Heidelberg, 2008. So the recruitment was 1994 to 1998. So it's 8 to 10 years follow-up here, right? And after these long follow-up, you have numbers of cancer cases, breast cancer, the most frequent one, 376, lung cancer, 130. So you can hardly do any analysis with these numbers. If we look then at the entire EPIC cohort with more than 500,000 participants, here you have sufficient numbers. And that was also the idea of EPIC to combine to get a reasonably large number of participants, of cohort participants, to 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 approach figures of incident diseases earlier and do the statistical analysis earlier as having only this small Epic Heidelberg cohort. Okay. How do we evaluate the associations between, we can keep the same example, between smoking and lung cancer in a cohort study? So in a cohort study, you already have learned that we estimate this time under risk in often expressed in person years. You can also do person months, but we are talking about years, so person years is a better one. And you can also, you know the number of cases that you assess during follow-up. And now the way you are calculating the relative risk here, this one, is that you made the ratio between the incidence rate among the exposed and the incidence rate among the non-exposed. And the incidence rate is the number of cases divided by the total time under risk for the non-exposed, for the exposed. No, yes, exposure, yes. And for the non-exposed, it's the number of cases in this non-exposed group divided by the time under risk, so these person years. So it's an incidence rate ratio. You have incidence rate in the exposed and an incidence rate in the non-exposed. And you make the ratio. This is what we call relative risk. And of course, we want not only the crude estimate, you can really calculate that by hand, but we want to have adjustments for confounding factors. And then it's more difficult. But let me show one example. It's a very famous example from Dolan Hill from the UK, where you have smoking status here, non-smoker, let's say moderate smoker, middle moderate, and smokers with more than 25 cigarettes per day. You have this person is calculated for each of the subgroups. You know the lung cancer cases, the number of cancer cases, the incident cancer cases, and then you can estimate the incidence rate, which means you divide, as you saw before, the number of cases through the person years. So which this means 0.07 subjects per 1,000 person years in this group of non-smokers. In the group of very strong smokers, it's 1.66. So it's what we expect to see. And if you then subdivide your crude incidence rate in one group against a reference group that you can define, here we define non-smokers as the reference group. So if you want to know what is the relative risk in the subjects who are smoking 1 to 14 cigarettes per day as compared to non-smokers, you calculate this incidence rate ratio. Here are the two incidence rates, and you make the ratio, which is 6.7, meaning that the risk in this group of subjects is 6.7 times the risk in the non-smokers. Yeah. Okay. And when we do additional adjustment, we go and use the Cox proportional hazard regression models, usually. There are also other methods, but that's what I always see. And I want to also show you one example from EPIC Heidelberg, where we looked at the question whether fruit intake is related to lung cancer risk, is associated with lung cancer risk. And you can see here quintiles of fruit intake and these relative risk estimates, which are here called hazard rates. Hazard ratios, sorry. The reference category is always defined as the lowest intake of fruit, and then the intake of fruit gets higher and higher. Here is the highest quintile, and you can see the relative risk decreases already in the second quintile. A very rough estimate, adjusted only for age, sex, and center. If you adjust fully without smoking, then not so much changes. But if you adjust very precisely for smoking, the situation is completely different. So that I just want to make this example to show you the meaning that you have to have a very full and precise adjustment for possible confounding factors, right? Okay. Let me say a few words at the end about the situation in Augsburg, where we are sitting. We are sitting here close to the University Hospital in Augsburg. It's a central hospital with I would say, unselected patients. And here you can see the map with the city of Augsburg and the two surrounding counties, which include about a population of about 650,000, more or less. And this is our study region. And in this study region, we have a lot of studies running. So the first one and the most mature one is the Monica Cora cohort study. This study started in 1984, at the time also when the myocardial infarction register started here in Augsburg. And this study started with 4 cross-sectional studies, and then the researchers decided to follow them up. And suddenly, by that decision, it became a cohort. And you have here these health cohort, sending out questionnaires 1, 2, period 3, period 4, period 5, and so on. Yeah. But people are getting older and older, so it was wise to start a new study, this new narco health study, where recruitment was between 14 and 19. And now the second examination is at its end, and the third examination will start soon. I don't want to talk too much about that study. So we have about 200,000 subjects Germany-wide, two study centers in Bavaria and one in Augsburg, with 20,000 subjects recruited here in Augsburg. So Professor Meising and me, we set up the study center here in Augsburg and made it up and running. And you can see that it took a lot of time between 2014 and 2019 to recruit 200,000 subjects. 30,000 of them also got an MRI examination, 1 hour in a research MRI. So it's a very nice database as well that we can use. We have to develop a scientific plan. That's what you see. That's what we submitted for funding. We were happy to get that funding. It was really a major funding. And we identified 4 specific um, um, scientific objectives, etiological pathways, so linking lifestyle factors or environmental factors with, yeah, here it's not listed only major chronic diseases, it's also listed functional impairments. So we wanted to have as many examinations as possible in that study. And you can see here a large range of devices and examinations that we did. Cardiovascular system related, diabetes related, cognitive function testing, lung function assessment, sensory organs, and so on. So we cannot go through all that, but I want to show you that we focused on functions as well, not only waiting at disease diagnosis, right? And what we at the chair of epidemiology in Augsburg also did when we started, we established next to this myocardial infarction registry different patient cohorts. What is a patient cohort? A patient cohort is a cohort of patients, in this case, this example is of stroke patients, that you recruit at a certain time. As for the population-based cohorts, you recruit here patients and then follow them up over time. The questions are a bit different, of course. So disease reoccurrence, comorbidities, progression or complication, or medical care needs and use, disabilities. So there are different questions, but it's also a cohort study design, right? Okay. Yeah, that's what I wanted to show you and tell you about these examples, cross-sectional studies, cohort studies, and show you also examples that we are doing that currently. Both types of studies we are doing. What we are currently not doing is case control studies. But all other types, I think we are running. Yeah, I hope I could yeah, illustrate some features, some needs, some limitations of each of the study designs. And if you have questions, you're welcome. I will answer your question or try to answer your questions. Thank you for listening.
Jakub, your presentation, a very good presentation. Its overview is very good, presentation. Now for the audience, they are just thanking you for your nice presentation. And I have some question, because you know that is, as an editor for the journals, usually now the number we have a surge or like huge number of submissions depending on like a publicity data which is available, for example, like open access data, biobank, UK bank, and so on. So now, just like I want to assure from you, is it a good data that we can just the authors, or it can be like a published, or how can we assess such paper without like, because I understand that you already like collecting the data from biobank or whatever, it's from publicity data, plus you are doing a kind of field work, right? So that you can just like validate your data, and then you can just have like a finding that could be that we could reach to something like about the finding. But to depend on publicity data or public available data only, is it good article that we can just we can just like publish in the journal? And as you are aware right now, we have a Mandarin randomization like studies, MR studies. A lot of papers are coming in that area, and it is just only published the data, and they are just doing some statistical analysis, analyzing the data, instrumental analysis, and that's it, without any like a preliminary data, as you see, because there is some kind of pilot test. You are saying the pilot test, and some are field field work, or some others like extra work. What's your opinion about this? Yeah.
Yeah, thank you for these questions. You made several questions. I'll try to be short in my answer, but the answer is very clear. There are many data, many studies out there, and which you can use. You made the example of UK Biobank. They made a perfect, or they developed a perfect system to use their data. And you, as a researcher, has to make the decision whether this is the right database for your question. And in many cases, it is the right database. So you have to have information about how this UK Biobank study was established. Um, for example, what is the participation rate? And if you want to make conclusions at the population level, maybe there are some things to consider. But if you focus on analyzing exposure outcome associations, then I would say it's a perfect database, provided that they have the information that you want to. That's often the problem. If you are interested in I don't know, physical activity, then you have to have a look what physical activity data did they collect. So they had their recruitment phase during, I would say, around 2010. And also using the devices, the standard devices at that time. These devices developed over time, and now they are completely different, probably. And you may want to analyze these newly collected data with a new device. Then you cannot use UK Biobank data. But I would say if you focus on a standard assessment and that did the people at UK Biobank, then there is no reason not to use this data. So that's fine then. And you mentioned it. The only point is then that you have a researcher who is aware and capable of applying the right statistical methods. And this is often the problem. Um, uh, Frankly, I recently applied for data from UK Biobank for a specific project where I do not have the data, and UK Biobank has the data. And the first thing that they wanted to have from me is also a description of my person, of my knowledge, of my statistical knowledge, and then the first hurdle is taken. So not everybody will get a data set from them. But if you can demonstrate that you have the necessary skills, you get this data set. You have to pay a small contribution, but that's fine. If you have a very specific question, and that's what we have in the case of our patient cohorts, and you cannot find open access data for these questions, then you have to go for an own new study and do the fieldwork. Or if the question is for this cross-sectional study, the question was, during this long time of 20 years, we do not have any information about what people eat in Germany. And it's really necessary. It's necessary, especially in terms of this discussion of sustainability of food, of eating less meat and less foods of animal origin and so on. So we need to have some information about what people eat in Germany. And that's why you have to do that study. You cannot get the data from elsewhere. So making it short, if you have the data elsewhere, you can use this data, but you only have to make sure that you have at your place somebody who has the right statistical expertise. If you cannot get hold of this data, you have to do a new study. So simple.
Yes, so this means now I got to the point that especially for example, like UK Biobank, they don't allow all the authors to give them like the data. They have to ask you what you will do, and they have to assure that you are expert in that or pioneer, and you have some understanding about like its data. So it's not like open the light for everyone like who want like to use like the biobank, right?
Right. Not everybody is allowed to use the data, but I don't know how strong um this success is regulated. At least I can tell you I will get the data.
Yes, because you are like you are expert like in that area like Yakub. So because it is now I can see from some of the paper that the authors are using are saying that they got the data from biobank. So now
Yeah.
like if they got they you say that at least they are aware about the statistical analysis and they can do a good statistical analysis. At least they publish related work in that area in epidemiology. So they are sure about that what the author wanted to use the data.
But the problem is, of course, if you need very sophisticated statistical methods, and I would say you ask for Mendelian randomization studies, this type of analysis is also a sophisticated analysis. UK Biobank cannot really see whether there is a sufficient experience or knowledge. So I would say, and we also see that there are a lot of papers in with Mendelian randomization
Yes.
analyses that
Mm.
we would judge not scientifically sound, I would say.
Mm.
So
So you mean like you
they
don't
cannot exclude that problem. They
so you
can
mean
li
that
they,
as expert that you don't like recommend or you don't like MR like this kind of MR analysis,
you know,
Mendelian
I
random.
like MR analysis, but the analysis have to be done precisely and state-of-the-art analysis. And I'm not sure in many cases whether what they have done in these
Mm,
examples. And UK Biobank is not able to differentiate here. So
mm,
yeah.
mm. Mm. And another one is like I hope you said for the cohort studies that you said it's like exposed and non-exposed. And in the last slide, you just like focus on like a very sample size, like it is for example, like you already focus on certain, for example, for certain disease or certain condition. How this is could be like to be like cohort studies.
Sorry, I didn't get your question. Your last
So
sentence. Can you repeat your last
yes,
sentence?
for cohort studies, like in the last few slides, you already say, especially in Germany, that it's like a patient cohort, and cohort, like as you already like mentioned before, this is like exposed and not in the beginning or first exposure. They are not disease. There is no disease, and then they are going to follow up several follow up.
Yeah, but I'm not sure whether I've got you correctly.
Yes, this
For,
one
for,
like
for the patient cohorts, you do not start with the healthy subjects, but you start with a certain
patient.
group of patients,
Ah,
like stroke patients, for example. Yeah.
tamam.
So we are recruiting all patients in the clinical hospital here um, at the time when they are inpatients. And then we
Hmm.
ask them different things. We're getting biosamples. We can get hold of the clinical data. And then we got their agreement that we can contact them further on. And
Hmm.
we send out questionnaires, usually questionnaires. Sometimes we also re-invite them for examinations, for re-examinations.
Hmm.
And we are interested in what happens with these patients. Or are there specific groups of patients that need more help, or that what happens with medication during the follow-up. So
Hmm.
a lot of patients may stop to use some type of
Medication.
medication that they got prescribed at the end of your hospital stay. So that's what we wanted to get this information about what is the fate of these type of patients.
Hmm.
Where are needs for improvement in the healthcare system, right?
Hmm. So you are very focused on patients rather than like starting with healthy and then started to see like what happened to them after a period of a study.
We are doing both. As I said,
Yes, yes,
just
but
a
which
moment.
one? Which
Here in
one is
Augsburg, we have these population-based cohorts, and in addition to these population-based cohorts, we have these patient cohorts established. So we have a very good view in this study population what is happening, right?
That's all Jakub from my German side. This is my questions. We are like happy and pleased to have you with us, and hopefully to see you again and again, to share with your experience as an expert person in epidemiology. So we would like to thank you so much for your presentation to our continuous medical education meeting, and hope to see you again. But this time in person. That you are welcome to visit Atatürk University. Thank you, Jakub, for your presentation. Have a good day.
Thank you very much. Thank you very much also from my side for the possibility to talk here. It was a pleasure. Thank you.
We are happy to be with you like that.
Dr. Insansın, thank you very much for your very beautiful presentation. See you next time. Goodbye.
Thank you. Bye-bye.